Hello, 6th grade. How are you doing? Today we're going to continue with the topic of division of fractions. Now remember, before you can divide fractions, you need to understand how to multiply them. We're going to be working on both page 19 and 20 today inside of our Prime book. So you will need both of those pages in Prime. And to start out, we're going to just watch a video. Now, I'm not sure if you know, but there's a very popular dessert in the culture in the United States that's called a brownie. It's become a little bit more popular here in Costa Rica, and it's delicious. There's so many different ways to make it, but it requires a lot of mix, the ingredients, right? The dough that you might need. So we're going to watch a quick video on BrainPop just so that you guys can understand the reason why we divide decimals. So take a listen.
Ew, how'd that get in there? Dear Tim and Moby, how do you multiply and divide fractions? From Joe. You're in luck, Joe. We're gonna have to multiply fractions to get through this brownie baking mess. Okay, we're baking for 40 people? Better not be as bad as it sounds. Well, 1½ kilograms of brownie mix will make enough brownies for 10 people. So, how many kilos of that mix will we need for 40 people? 40 tenths times 1½ We can reduce that first part to make it easier. 40 divided by 10 is the same as 4 over 1. Let's get that 1½ out of its mixed number form. 1 times 2 halves equals 2 halves, plus 1½ is 3 halves. When you multiply fractions, you multiply the numerators and denominators separately. 4 times 3 equals 12, and 1 times 2 equals 2. 12 halves is 6. So we need 6 kilograms of brownie mix? You need that in grams? Okay. Well, 1 kilogram equals 1,000 grams. So we can multiply 1,000 by 6 pretty easily to get 6,000 grams. But I just told you. Okay, fine. I'll show you how to do it by dividing fractions. We'll start with our original fraction, 12 divided by 2. Now, to figure out how many grams that is, you can divide by the fraction 1 kilogram over 1,000 grams. Dividing by a fraction is the same as multiplying by its multiplicative inverse. That's math speak for an upside-down fraction. To get that, you just flip it. 12 times 1,000 is 12,000. 2 times 1 is 2. And 12,000 halves equals 6,000. All right, Moby, it's confirmed we need 6,000 grams of brownie mix. You can't just quit. This was your idea.
Alright, so that gave you a better understanding of a reason why we would multiply or divide fractions in real life. Let's go to page 19 and we'll do a couple of these problems together. On page 19 we have just 2 problems on the bottom that I would like to do. We already did the top problem, so we're now just doing the ones on the bottom, okay? Alright, letter 2A on the bottom on page 19 says that we're going to divide 1/4 divided by 1/8. Now we know that that's the same thing as 1/4 times its reciprocal, which is 8, or in this case, 8 over 1. So we can easily simplify or multiply those fractions. 1 times 8 is 8, and 4 times 1 is 4. Now right away you can probably notice that we have a whole number hidden inside of that fraction. And 8 over 4, or 8/4, is the same thing as 8 divided by 4. It's just a division problem, right? Any fraction is really just a division problem. 8 divided by 4 is 2. So our final answer is 2. Since we have a whole number, we don't need to simplify the number anymore. Let's do letter B. on the bottom of page 19. 3/5 divided by 9/10 is the same thing as multiplying the second number by the second number as a reciprocal, just like the video explained and like our last class. So we're going to take 3/5 times its reciprocal, which is 10/9. Now right away I see that I can simplify these fractions. For example, I can, if I wanted to, divide both 3 and 9 by 3. If I divide 9 by 3 and 3 by 3, that's going to give me 1/3. And if I divide 5 and 10 by the same number, in this case divided by 5, on both sides, that's going to give me 2 and 1. In other words, I'm multiplying now 1 times 2 and 1 times 3. That's pretty simple because we can just get rid of these ones right here, and we have 2/3. Our final answer is 2/3. All right, let's do the next problem on the next page. So now we're going to go to page 20. We're going to find a whole lot more difficult problems. This time we're going to be simplifying fractions, changing improper fractions to mixed numbers, and trying to find whole numbers within our improper fractions. The directions on page 20 say that we need to express each answer in its simplest form. So let's do that. On page 20, you'll notice the first problem is 1 divided by 1/3. Well, 1 divided by 1/3 is the same thing as 1 times its reciprocal. So if we find the reciprocal of 1/3, it's just 3/1. Now 1 times 3 is 3, and 1 times 1 is 1, which leaves us with 3 divided by 1, which equals 3. Letter B is pretty simple too. If we multiply it by the reciprocal, 2 divided by 2/9 is 2 times 9/2. And if I really wanted to put a 1 underneath the 2, I could do that. Okay, now there's several ways that we could do this problem. We could take 2 times 9, which gives us 18, and 1 times 2, which gives us 2. And then we could simplify that and find our final answer. Or what we could do is if we notice that, for example, we noticed that this 2 and this 2 are the same, we just cancel them out by dividing both of them by 2, which means that we're left with 9/1, which is our answer, 9. 18 divided by 2 equals 9. All right, let's do letter C. Letter C says 1/2 divided by 2/3. If we take 1/2 divided by 2/3, again, we are multiplying by the reciprocal of the second fraction. So this changes to a multiplication sign, and this changes to 3/2. 1 times 3 is 3, and 2 times 2 is 4. So we're left with 3/4. That's already as simple as it comes, because if we draw this out, separate a circle into 4 equal sections, and color them, we have no whole numbers, and we have no mixed numbers, so that is our final answer. If the small numbers on the top are numerator and the big numbers on the bottom, you have as simple as a fraction as it comes. All right. What we're going to do for the next one is the same procedure that we've been doing over the past couple of problems. We're going to multiply by the reciprocal. In other words, flip this. Now it becomes 4/3. I'm just going to cross off that fraction just so we're not distracted. Now we have 5 times 4 over 8 times 3. Can we simplify any of these fractions? we sure can. If we divide 8 by 4 and divide 4 by 4, we're left with 5 times 1 over 2 times 3. You'll notice this number and this number did not change, but since we simplified or divided by the same number in this one, this number, and this number, they did change. Okay? We did have these two numbers change. All right, 5 times 1 is 5, and 2 times 3 is 6. We're left with 5/6. That is our final answer. All right, we're going to do the other two problems, the other four problems that are on the bottom of page 20. Letter E is the first one. If you need to check your answers in any one of these, you can check them. Here's another way that I did it. I just multiplied across and found 20 over 24, and then I divided both sides by 4 to get 5/6. So that's just another way of doing it. There's plenty of ways to do these problems. Okay. For letter E, we're going to follow the same exact procedure that we've been following. Okay. So multiply by the reciprocal. Again, if you don't understand why we multiply by the reciprocal, you can go back to this page right here where Mr. Joseph explains exactly why we are multiplying by the reciprocal. That is in the last lesson, and I will put a link in the description just so you can understand it a little bit more. Okay, let's go back to that problem on the bottom. Letter E we were on, I believe. Yep, okay. So 5 times 9 is a pretty big number. So what I'm going to do is just simplify these, okay, just like we've been doing before. I see that there's a 9 right here and a 9 right here, so I can actually divide both sides by 9. Divide 9 by 9, and that equals 1. And then divide 9 by 9 again, and that's going to give me 1 as well. Okay? So since that goes away, I can just kind of cross it off, right? And we're multiplying 5 by 1 and 1 by 4. So our fraction that we're left with is 5/4. If you want me to write that out completely like I had been before, it's 5 times 1 over 1 times 4, which equals 5/4. Now this fraction is not simple. We need to simplify it. This is an improper fraction, which requires simplification. Okay? I know that I can find a whole number within my improper fraction just by separating it out. Well, 5/4 is the same thing as 4/4 plus 1/4. I know that because 5 equals 4 plus 1. Now this right here converts into a whole number, right? Can change that to 1, and this just stays the same, 1/4. Okay? So our final answer for letter E is 1 and 1/4. If I were to draw that out, I could show you that. I'll draw that out. If we have, for example, 5/4, we have this fraction right here. What happened? Seem to not be able to write on the board for some reason. Oh, that's because I changed my color to white. Very smart. Okay, there we go. If I have this fraction right here, 5/4, I can actually draw that out, just like I did with the previous problem. Split these up into fourths, and then color in my equal parts. So 1/4, 2/4, 3/4, 4/4, 5/4. You can see this is 1 and 1/4, which is the same thing as my answer right there. Okay, I'm going to erase a couple of spots just here, just so I have a little bit more space to do the next problem. All right, our next problem says 9/11 divided by 3/4. Now 9/11 divided by 3/4 is the same thing as multiplying by its reciprocal, like we've been doing before. So multiply by 4/3. And I could simplify if I wanted to. 9 and 3, both of them divided by 3, so that I would be left with 3 times 4 over 11, 3 elevenths over 1, right? Because I divided both of them by 3. 9 by 3 and 3 by 3. So that gives me 12 elevenths, which again is an improper fraction. So I can find its whole number, which equals 11 over 11 plus 1 over 11. In other words, my final answer is 1 and 1/11. Okay? You'll notice that I found the whole number. 11 over 11 is my whole number. Okay? That's a completely whole number. There's no fractions within there. Any number over itself is always 1. All right. So I'm going to go to the last 2 problems. Now, since we only have 2 more problems, I'd like you to pause the video and I'd like you to do these problems on your own. Okay, so if you could do letter G and H on your own, pause the video and try to see if you can do these ones on your own. They are a little bit more difficult, okay? You're going to find some pretty big numbers in your fractions, but like I said before, I'd like you to find the whole number first and then break that up into the separate smaller fractions. All right, so hopefully you pause the video and you're able to do this problem on your own. We're going to check the answers just to make sure you did them okay. I'm going to multiply by my reciprocal in both instances. So we have 7/3, all right? And 7 times 7 is 49. And 8 times 7 is 56. Which is interesting because it's a relatively big number, okay? I don't want, oh, actually, no, that's not correct. That would be 7 over 3. Didn't look right. Okay. 7 times 7 is 49. And 8 times 3 is 24. This is as improper as it comes because the big number is on the top and the small number is on the bottom. I can separate this out into, well, I know that 49 equals, 24. Okay, here we go. 24 plus 24 plus 1. Right? 24 plus 24 plus 24 equals 49. So how can we simplify this more? Well, I know that 24 24ths and 24 24ths both equal 1. So we actually have 2 as our whole number plus 1 24th, which is left over. So in other words, our final answer, which I'll put in blue, equals 2 and 1 24th. There's our final answer. Okay, let's do the last problem. Check your answers. We're going to multiply by the reciprocal, which is 9/7. 11 times 9 and 12 times 7. Can I simplify these even more? I sure can. I don't want those big numbers. Confuses my brain. So we're going to, here's our numbers right here, 11, 12, 7, and 9. We can divide both 9 and 12 by 3. Let's do that. Divide by 3. And divide by 3. So our new problem is going to be, let's see, this equals 3, and this equals 4. So our new problem is 11 times 3 over 4 times 7, which equals 33 over 28. Also, that is improper. So how do we figure out 33 over 28? Well, I'm just going to break it out into its separate parts, right? So we have 33 over 28 equals 28 over 28. Again, I'm finding my whole number. And how much more do we need to get into 33? Well, let's see, 27, 26, I'm sorry, 29, 30, 31, 32, 33. We have 5 28ths left. So our final answer is 1 and 5/28. I'm going to write that in blue, or like this purplish color. Okay, so I have that 1 right here. This is our whole number. 1 and 5/28. That is our final answer. Okay, hopefully you understood this topic a little bit more of dividing dividing fractions. It is rather complicated, so I would suggest that you do some practice problems that we've done before. If you don't understand them, do them all over again. You can also go to this game right here that I have, that I sent in the last video. You guys can play that game if you really want to. Where's the link? It's got to be here somewhere. Here we go. This math playground game is fantastic to practice dividing fractions. If you didn't play it last time, you should play it this time. It is phenomenal in order for you to get that understanding really down pat. So here you go. There's an example of the problem. And then also we played a Kahoot last time, which we will most likely repeat for the next class. Just understanding making improper fractions to mixed numbers. These are a couple of the problems that we will most likely play for next class. So we'll talk to you later, 6th grade. Enjoy your weekend.